Hello everybody. In this video we're going to learn how to handle three integrals with rational functions. 1 over 1 plus 9x squared, 9x over 1 plus 9x squared, and 9x squared over 1 plus 9x squared. Let's begin. Let's check out 1 over 1 plus 9x squared from 0 to 1 over 3. For this integration, we need to remember arctangent. We know that integral of 1 over 1 plus u squared is arctangent of u, or derivative of arctangent of u is the integrand 1 over 1 plus u squared. We know that arctangent function has domain from negative infinity to positive infinity and range from negative pi over 2 to pi over 2. After knowing these basic facts, we can start solving this integral. Let's do u substitution, but first we need to express 9x squared in the form of u squared. So let's rewrite this integral. Integral from 0 to 1 over 3, 1 over 1 plus 9x to the second can be written as 3x, the quantity squared. And then we can do u substitution. Let u be equal to 3x. Then du will be derivative of this, will be 3dx. And if you solve for dx here, dividing both sides by 3, dx will be 1/3 du. Now let's rewrite everything in terms of u. Our integral from 0 to 1 over 3 of 1 over 1 plus u squared, and instead of dx we have 1/3 du. We can write du here and pull 1/3 in front of the integral sign. Now we know that the integrand now is arctangent of u. So antiderivative of 1 over 1 plus u squared is arctangent of u. So we have 1/3 arctangent of u, and we can bring u back. Our u was 3x. 1/3 arctangent of 3x from 0 to 1/3. Now we can apply the special values of arctangent. Here we are going to apply first fundamental theorem of calculus, upper boundary minus lower boundary. So we have 1/3 arctangent of 3x minus 1/3 arctangent of 3x. Our upper boundary is 1/3, so we are going to insert here 1/3. And our lower boundary is 0, so we're going to insert here 0. So we will have 1/3 arctangent of 3 times 1/3 is 1, and 3 times 0 is 0, so it will be 1/3 arctangent of 0. Now let's check out the special values of arctangent. This is what we obtained in the end of integration. Arctangent of 1 is equal to pi over 4, so we have 1/3 times pi over 4 from arctangent of 1, checking the special values of arctangent, minus 1/3 times arctangent of 0 is 0, as you can see graphically or table wise. So this is 0, and 1/3 times pi over 4 is pi over 12. So integral from 0 to 1 over 3 of this integrand is pi over 12. Let's check out this time integral of 9x over 1 plus 9x squared. Again from 0 to 1/3. As we observe that this is not arctangent because our numerator is not just a number, we have a variable in the numerator. Let's rearrange this integrand. we can pull 9 in front of integral sign because it's 9 times x. Integral from 0 to 1/3 of x over 1 plus 9x squared. This time we're going to do u substitution on the denominator. So let u be equal to 1 plus 9x squared, and the u will be derivative of this. Derivative of 1 is 0, derivative of 9x squared is 18x to the 1 dx, using the power rule. And if you solve for dx here, dx will be du over 18x. Now let's rewrite everything in terms of u. Our integrand turns into 0 to 1/3. We have 9 in front. X over, instead of 1 plus 9x squared, we have u, because we said that it's u. And instead of the x, we have du over 18x. Here x is cancelled out, and we have 1 over 18 that we can pull in front. So it will be 9 over 18, which is going to be 1/2. And we have 1 over u. Let's remember, integral of 1 over x dx is equal to ln of absolute value of x. And derivative of ln of x is 1 over x. So knowing this fact, antiderivative of 1 over u is ln of u. So our integral turns into 1/2 ln of absolute value of u plus c. But in our case, this is definite integral from 0 to 1/3. First, we bring u back. 1/2 ln of 1 plus 9x squared from 0 to 1/3. Now we apply fundamental theorem of calculus. Upper boundary minus lower boundary. We have 1/2 ln of 1 plus 9. Instead of x, we have upper boundary 1/3 the quantity squared minus 1/2 ln of 1 plus 9 times, instead of x, we have lower boundary. Zero squared is 0, 0 times 9 is 0, plus 1 is 1. So second part of the integrand is ln of 1. And we know that ln of 1 is equal to 0. And the first part of the integrand will be 1/2 ln of 1/3 squared is 1 over 9 times 9 is 1, 1 plus 1 is 2, so it's going to be ln of 2. So we have 1/2 ln of 2 minus ln of 1. So ln of 1 is 0, so this is going to be 0. So our final answer is 1/2 ln of 2. Let's finally check out 9x squared over 1 plus 9x squared from 0 to 1/3. First, let's pull out 9 in front of integral sign because it's in the multiplication form. So we have 9 times integral from 0 to 1/3 of x squared over 1 plus 9x squared. We see that this is not directly arctangent because numerator is not just a number, it's a variable. We can't use u substitution just for whole denominator because derivative of this is not cancelling x squared. So what we're going to do here is to make the numerator look like the denominator using algebraic manipulation. our integral from 0 to 1/3, our denominator is 1 plus 9x squared. So our x squared, we multiply it by 9, add 1, and if we multiply it by 1 over 9 and subtract 1 over 9, actually we don't change anything, because this expression is equal to x squared over our common denominator, 1 plus 9x squared. Let me show you that 1 over 9 times 1 plus 9x squared minus 9 is x squared actually. 1/9 times 1 is 1 over 9. 1/9 times 9x squared is just x squared, and we have negative 1 over 9 here. They cancel each other, so we have just x squared. So all we did on the numerator is just algebraic rearrangement. So we can obtain 1 plus 9x squared that can easily interact with the denominator. Now what we're going to do is to split this into two integrals. This is going to be our one integral, and this is going to be our second integral. So our integral, 9 times integral from 0 to 1/3 of the first part, 1 over 9 times 1 plus 9x squared, over the common denominator, 1 plus 9x squared. We have minus sign here, 0 to 1/3 of 1/9 over 1 plus 9x squared. Here we can pull 1 over 9 in front of integral sign and multiply by 9, so it's gonna be 1, so they cancel each other. So integral from 0 to 1/3 of 1 plus 9x squared over 1 plus 9x squared. And we know that anything divided by itself is 1, so integral from 0 to 1/3 of 1 dx, antiderivative of 1 with respect to x is just x. And if we apply fundamental theorem of calculus, it's gonna be 1/3 minus 0, upper boundary minus lower boundary. So from the first part we obtain just 1/3. So our first part is just 1/3. Let's take care of the second part. Again, we pull 1/9 in front of integral sign, and they cancel. So we have 1 over 1 plus 9x squared dx. Let's remember, integral of 1 over 1 plus x squared is arctangent of x, or derivative of arctangent of x is 1 over 1 plus x squared. And actually we remember from the previous example, integral from 0 to 1/3 of 1 over 1 plus 9x squared was equal to pi over 12, using the special values of arctangent. So now we have 1/3 minus pi over 12. And if we simplify these fractions, we can expand this by 4, so it's going to be 4 over 12 minus pi over 12. So our final answer will be 4 minus pi over 12. If you would like to see the detailed solution of the second part, you can check the previous example. I hope now you have more awareness on these three different types of rational integrands, so you can easily take care. Thank you for watching.